A cursor moves on its own, finds a button, and clicks it. Claude can see your screen and drive it. Welcome to AI Tech Book. Today, computer use how an agent drives a screen with a mouse and a keyboard and what changes when its eyes are a screenshot. Here's the whole thing in one cycle. The agent loop. Step 1, the agent takes a screenshot. That's how it sees. There's no API, just a picture of the screen. Step 2, it decides. It reads that screenshot, picks an action, and picks a place on screen to do it. Step 3, the action runs, the cursor moves, it clicks, it types, and then a new screenshot comes back and it goes again. Screenshot, decide, act. Screenshot, decide, act, without you in the middle. It's a stateful multi-turn cycle that runs until the task is done. Its eyes are a screenshot, its hands are a cursor, and this loop is the engine. Everything else about computer use follows from it. So what exactly can those hands do? The agent doesn't get a tool built for your task. It gets general computer skills, a handful of verbs. It can take a screenshot, move the mouse, click, left, right, or double, drag from one point to another, type text, send keyboard shortcuts, scroll, and zoom into a region to read it at full resolution. That's the whole vocabulary, the same one you use without thinking. And because the verbs are general, not task specific, the agent can operate almost anything a person can. But when it clicks, how does it know where? When the agent clicks, it isn't calling a button by its name. It's naming a point in the image. Here's the part people miss. It reads the screenshot and returns a coordinate, an X and a Y in pixels. When it clicks submit, what it actually emits is left click at 500, 300. It's aiming at a pixel. That's what makes it universal. It works on anything you can see. And it's also what makes it fragile. If the layout shifts, the pixel moves, and the aim is off. So if it can aim at any pixel, what can it actually drive? Because it drives the screen the way a human does, it can drive things that have no programmer's door in at all. Most tools need an API, a clean programmatic way in. Computer use doesn't. If a human can operate it on a screen, the agent can too. The legacy app with no integration, the internal tool nobody documented, the website with no API. It drives all of them. On Web Arena, a benchmark of real website tasks, it reaches state-of-the-art among single-agent systems. The universal fallback, no API, but still a screen. So why not use it for everything? 2 costs. It's slow, and it sometimes believes it succeeded when it didn't. First, latency. That loop, screenshot, think, act, screenshot, takes seconds per step, far slower than a person. So you point it at work where speed isn't the point. Background research, automated UI testing, overnight runs. Second, it sometimes assumes the outcome of an action without checking. It clicks and moves on, even if nothing happened. The fix lives inside the loop. After each step, take a screenshot and verify the result before continuing. Slow by nature, overconfident unless you make it relook. And there's a third cost, the most dangerous one. The screen isn't just output the agent reads, it's input the agent obeys, and the page can lie. Here's the trap that makes computer use uniquely dangerous. The agent reads the screen to decide what to do. So the text on that screen is input, and it will sometimes follow instructions it finds in the content, even when they conflict with yours. A malicious line on a web page, or hidden inside an image, can override your task and steer the cursor to the wrong thing. It's prompt injection through pixels. The agent's own eyes are the attack surface. You can't trust the screen. So how do you run it safely? You don't make the screen trustworthy. You make a hijack harmless. 3 layers. 1, run it in a sandbox. The reference setup runs inside a container, so the worst a hijack can do is wreck a throwaway environment. 2, withhold sensitive data. Don't hand it logins or secrets it doesn't need, so there's nothing to steal. 3, a human at the trigger for anything with real-world consequences, a payment, accepting terms, a delete. Anthropic also runs classifiers that flag suspected injection in a screenshot and make the agent stop and ask. It's least privilege and escalate the irreversible applied to an agent with hands. So, where do people still get burned? 4 traps. Each hands the screen too much trust or too much power. 1. Use it for speed critical work. It's seconds per step, it will never keep up. 2. Run it on your real machine with real credentials. 1 injected page, and your secrets walk out. 3. Let it click the consequential action, pay, delete, accept, with no human. 4. Trust that it succeeded without a verify screenshot. It'll march right past a failure it never saw. Every trap forgets the same thing. The screen is slow, untrusted, and the agent is overconfident. Speed, insensitive work, sandbox with no secrets, a human on the irreversible, and verify every step. So the answer, when and how do you let an agent drive a screen? Computer use is the universal fallback. When there's no API, there's still a screen. It sees a screenshot, aims at a pixel, and loops. Use it where speed isn't the point. Run it in a sandbox with no secrets to steal. Force a verify screenshot after every step. And keep a human at the trigger for anything irreversible, because the screen it reads is untrusted input. It sees a screenshot and aims at a pixel, universal, but slow and untrusted. The whole thing one screen. The loop, screenshot, decide, act, then screenshot again. It aims at a pixel, an X, and a Y. It drives any GUI, even with no API. It's slow and overconfident, so verify every step. And the screen is untrusted input, so sandbox it and keep a human on the consequential click. It sees a screenshot and aims at a pixel, universal, but slow and untrusted. That's computer use, agents that drive a screen. If this showed you something new, share it with one person automating a GUI. Subscribe to AI Tech Book, one architecture concept every episode. Thanks for building with us.